Hello students, I hope you all are doing good. We are going to start with a new session of surface areas and volumes. This is the third session of this chapter. Before that, let us move forward and see what are the learning outcomes of this session. Volume of different solid figures. Also, you will be learning about the method of converting one solid into another. So, let us revise our initial concepts. First, we have volume of a cube. Volume of a cube is given as V is equal to A cube. What is A? A is the edge of the cube. Similarly, volume of the cuboid is given by length into width into height. What is the length? This is the length of the cuboid. Similarly, this is the width and this is the height of the cuboid, right? So, length of the cuboid is given by this. Moving forward, we have volume of a cylinder. Volume of a cylinder is given by pi r square h. This is r, the radius of the cylinder, and this is h, the height of the cylinder. Similarly, the volume of the cone is given by 1 by 3 pi r square h. Now, again this is the radius or r of the cone and this is the height or h of the cone. Okay? So, moving forward, we have the volume of a sphere. It is given by 4 by 3 pi r cube. This is the radius of the sphere. And what is the volume of a hemisphere? It is half of the sphere. So, it is 2 by 3 pi r cube and r is again the radius of the hemisphere. So, let us move forward and see the application of these formulas. A cone of height 24 centimeter and radius of base 6 centimeter is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. So, initially we have a cone and this cone is reshaped as a sphere, right? So, volume of the cone can be given as, what is the formula for volume of cone? It is 1 by 3 pi r square h, right. So, substituting the value of r as 6 and h as 24, we have 1 by 3 into pi into 6 into 24 centimeter square. Also, let us take r as the radius of the sphere. Then, volume of the sphere is given by 4 by 3 pi r cube. Also, we know that since the volume of the clay the child is playing with is same. So, volume to form the cone and volume to form the sphere will be same. So, 4 by 3 pi r cube will be equal to 1 by 3 into pi into 6 into 24. We can cancel pi with pi and solving it further for r, what we have is r is equal to 6. So, what is r? R is the radius of the sphere. R is the radius of the resulting sphere. So, radius of the sphere will be 6 centimeter. I hope this question is clear. So, let us move forward to our next question. Selvi's house has an overhead tank in the shape of a cylinder. This is filled by pumping water from a sump, an underground tank, which is in the shape of a cuboid. A sump has dimensions of 1.57 meter into 1.44 meter into 95 centimeter. The overhead tank has its radius as 60 centimeter and height as 95 centimeter. Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which has been full. Compare the capacity of the tank and that of the sump. Here we will use pi as 3.14. Now, this is the cylinder and that is the sump in the shape of a cuboid. The volume of water in the overhead tank equals the volume of water removed from the sump. The volume of the water in the overhead tank is pi r square h. Why pi r square h? Because it is a cylinder. Substituting the value of pi in the question, it is given pi is 3.14. So, substituting the value of pi as 3.14, radius as 0.6 and height as 0.95, we substitute the value and we find the volume of water in the overhead tank as this. Also, the volume of water in the sump when full, when it is completely full, is L into B into H, which is the volume of the cuboid. So, substituting here again, we have 1.57 into 1.44 into 0.95 meter cube. Moving forward and calculating it further, we have volume of water left in the sump, left out in the sump after filling the tank will be volume of the total sump minus volume of the tank. Subtracting this both, we have this value, right. What is this? 1.57 into 0.6 into 0.6 into 0.95 into 2 meter cube. Now, volume we have found. Okay. So, what we need is, we need the height of the sump, height of the water left in the sump. That will be water left in the sump divided by L into B, that is length and breadth of the sump. So, calculating this further, what we have is substituting the value here, volume of the water left in the sump is this divided by length into breadth. Calculating this further and simplifying it, we have 47.5 centimeter. Also, we know that capacity of the tank divided by capacity of the sump will be volume of the tank divided by volume of the sump. This gives out 1 by 2. So, capacity of the tank is half, that is 1 by 2 of the capacity of the sump. I hope this question is clear. Let us move forward to our next question. A hemispherical tank full of water is emptied by a pipe at the rate of 4/7 liters per second. How much time will it take to empty half the tank if it is 3 meter in diameter? Here the pi is taken as 22/7. So, let us move. This is a hemispherical tank. Radius of the hemispherical tank is given as 3/2 meters. This is the radius and this is 3/2 meters. Now, volume of the tank will be volume of the hemisphere. It is 2/3 pi r cube, right. So, substituting the value of pi as 22/7 and radius is 3/2. Substituting and simplifying, we have 99/14 meter cube. This is the volume of the tank, right. So, volume of the water to be emptied will be half of the tank, right. So, half of the volume, this is half of the volume. Multiplying by 1000, why are we multiplying by 1000? Because we want to convert meter cube into liters and we have 99,000/28 liters. So, moving forward, we have, since 25/7 liters of water according to the question is emptied in 1 second. So, we have this much liters of water to be emptied. So, how much time will it require? It will be this multiplied by 7 divided by 25 and we have 16.5 minutes. Converting these seconds into minutes, we have 16.5 minutes. I hope this question is clear. So, let us move forward to our next question. A metallic sphere of radius 4.2 centimeter is melted and recast into the shape of a cylinder of radius 6 centimeter. Find the height of the cylinder. Students, you need to understand, when a metal is reshaped, the volume remains the same. Okay? So, radius of the hemisphere, let us take it as R1. This is the radius of the hemisphere, which is 4.2 centimeter. Okay? Radius, that is R2 of the cylinder, is 6 centimeter. Here it is given as 6 centimeter. Now, let us take the height of the cylinder be h. Let us take this as h. Now, object formed will be same volume. The object formed reshaped by from a metallic sphere to a cylinder will be same in the volume. So, volume of the sphere will be equal to volume of the cylinder. So, let us calculate substituting the formulas. This is the volume of the sphere which is equal to volume of the cylinder, right. Here the radius is different. So, we have R1 and R2. Pi is same on both sides. So, we can cancel out pi and we have 4 by 3 R1 cube is equal to R2 square h. Now, we can find the value of h in terms of the radius. Why in terms of radius? Because we know the value of radius of the sphere as well as radius of the cylinder. Substituting the values, we have the value as 2.74 centimeter. So, this is the height of the cylinder. This is the height of the cylinder formed from the sphere, which is 2.74 centimeter. I hope this question is clear. So, let us move forward to our next question. A well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. This is a well and we take out mud from it, right, and we take out mud from it and spread it around the well to form an embankment, and this embankment is of the shape of a cylinder, right, or we can say a ring wherein we have an inner radius as well as the outer radius. We can clearly observe that the shape of the well, this shape of the well is cylindrical and the earth evenly spread out like this, evenly spread out to form the embankment around the well is like a circular ring wherein we have the inner radius as well as the outer radius. So, volume of the earth taken out from the well, this is the earth taken out from the well and spread it evenly here, right. So, volume of the earth taken out from the well will be equal to volume of the earth used to form the embankment. So, volume of the cylindrical well, this volume will be equal to volume of this embankment, right. This is the embankment, right. So, both these volumes are equal. So, let us calculate. The shape of the well will be cylindrical. So, depth of the well or h1, what we call the height, is 14 meters and radius, let us take it as r1 of this circular end is 3 by 2 meters, that is 1.5 meters. Now, width of the embankment, width is this much, it is given as 4 meters. Inner radius of the embankment, that is r1, this is the inner radius, this is same as the well, which is 3 by 2 meters or 1.5 meters. Outer radius of the embankment, that is capital R, it is given by inner radius plus the width of the embankment, which is 1.5 meters plus 4 meters, which can be given as 5.5 meter. So, the outer radius, this one, this is 5.5 meters, right. So, we have the inner radius and the outer radius of the embankment. So, let us solve it further. Height of the embankment, let us take it as h. This is the height of the embankment. So, volume of the cylindrical well, this will be equal to volume of the hollow cylindrical embankment. Substituting all the formulas, we have pi r square h1, that is the volume of the cylinder, the well, and pi r square h, capital R is the outer radius of the embankment, and pi r square h, small r is the inner radius of the embankment, and h is the height of the embankment. Substituting the values or taking common, we have r square h1 as h common, capital R minus small r, capital R plus small r. Now, all we need is to substitute the values. Substituting the values, solving it further and simplifying it, we have 1.125 meters. What is this? This is the height of the embankment, right? This is the height of the embankment, which comes out to be 1.125 meters. I hope this question is clear. So, let us summarize this session. You have already studied about the volume of the cube as V is equal to A cube. What is A? A is the edge of the cube. Also, volume of the cuboid is given as length into width into height. Volume of cylinder is pi r square h. What is r and what is h? If this is a cylinder, then r is the radius and h is the height of the cylinder. Similarly, volume of cone can be given as V is equal to 1 by 3 pi r square h. This is r, the radius of the cone, and this is h, the height of the cone. Also, volume of the sphere is 4 by 3 pi r cube. If this is a sphere, then r is the radius of the sphere. Also, hemisphere, the volume of hemisphere is half the volume of the sphere, that is 2 by 3 pi r cube. If this is a sphere, then this is the radius of the hemisphere. So, also you have studied about the application of all these formulas in converting one type of solid into another. I hope all these concepts are clear. Have a nice day. Thank you.